We're going to use the definition of the derivative to differentiate f of x equals to sine squared of x. Now sine squared of x is just sine of x times sine of x, which we can also write as sine of x squared. So we'll use these two notations interchangeably in this problem. Recall the definition of derivative, that's f prime of x is equal to limit as h approaches 0 of f of x plus h minus f of x divided by h. We have to use the definition of the derivative in this problem. We cannot use product rule or the chain rule. Now we're going to need a couple of results to make the computations easier. The first result is a trigonometric identity, and I'm going to use the variables for this problem, that is the sine of x plus h equals to sine of x times cosine of h plus sine of h times cosine of x. And then the second result we'll need is a familiar result, limit as h approaches 0 of sine of h over h, and that limit equals 1. This was shown in an earlier video and we used it many times in other videos. So let's begin the computation of the derivative of sine squared of x. We'll use the four-step process. In the first step, we're going to compute f of x plus h and simplify it as much as possible. So here it is sine of x plus h. We'll replace the x with x plus h squared. We're going to use our first result, the trigonometric identity, to expand sine of x plus h. We'll write it as sine of x times cosine of h plus sine of h times cosine of x, and of course it is squared, and so this will equal to sine squared of x times cosine squared of h plus twice the product of the two things that we're adding, so twice sine x cosine h times sine h cosine x, and then plus sine squared of h times cosine squared of x. And that's the end of step 1. There's nothing more that we can do as far as simplifying this. In step number 2, we're going to take the result of step 1, f of x plus h, and subtract f of x. So this is right from the line above, sine squared of x times cosine squared of h plus 2 times sine of x cosine of h times sine of h cosine of x plus sine squared of h times cosine squared of x, and subtracting f of x, which is sine squared of x. We want to simplify this as much as possible. Note that this term contains a factor of sine squared of x, and so does this one. And so we're going to factor sine squared of x out from the first and the last term. That leaves cosine squared of h minus 1. Everything else stays the same, so plus twice sine of x times cosine of h times sine of h times cosine of x, and then plus sine squared of h times cosine squared of x. There's one more thing that we can do here, and that is, notice that we have cosine squared of h minus 1 here. So that's sine squared of h plus cosine squared of h. Of course, that's equal to 1. Solving for cosine squared of h minus 1, we get negative sine squared of h. So we'll replace this cosine squared h minus 1 with negative sine squared of h, and the negative we'll put that in front. So the final result at the end of step 2 would be minus sine squared of x times sine squared of h, and then plus twice sine of x times cosine of h times sine of h times cosine of x, and plus sine squared of h times cosine squared of x. Let's go to step number 3. Step number 3 involves just taking the result of step 2 and dividing it by h. So here's step number 3. We want to compute and simplify f of x plus h minus f of x, and that's divided by h. So since there are 3 things that we have at the end of step 2 that are added, we're going to divide each of them by h. So this is minus sine squared of x times sine squared of h divided by h, plus twice sine of x cosine of h sine of h cosine of x, also divided by h, and then plus sine squared of h times cosine squared of x divided by h. Now we want to simplify this as much as possible. Notice that every one of these 3 terms has a common factor, which is sine h over h, and that's what we're going to factor out. So I'm going to factor out sine of h over h, and then in brackets write whatever is left for each term. In the first term, when we factor out sine h over h, we get minus sine squared of x times sine of h. In the second term, we get twice sine of x times cosine of h times cosine of x. And in the third term, we get sine of h times cosine squared of x. And now we're ready for the last step. That is step number 4, where we actually compute the derivative. So step number 4 is f prime of x equals to the limit as h approaches 0 of f of x plus h minus f of x divided by h. And this becomes the limit as h approaches 0 of a sine of h over h times minus sine squared of x times sine of h plus 2 sine x times cosine of h times cosine of x plus sine of h times cosine squared of x. And now let's go ahead and compute this limit. First, the second result, this limit as h approaches 0 of sine h over h, that goes to 1. Over here we have sine h, that goes to 0 as h goes to 0. Sine squared of x is not affected because it doesn't have an h. In the second term, we have cosine of h. As h goes to 0, that heads to cosine of 0, which is 1. And then here, we also have sine of h. That is heading to 0 as h goes to 0. And so when we look at this, the only thing that survives is in the second, in the middle here, 2 sine x cosine x. So this limit is equal to twice sine of x times cosine of x, and that is the derivative we're looking for. So to summarize, we wanted to compute the derivative of f of x equal to sine squared of x. Using the definition, the 4-step process, and a couple of results, trig identity, and a limit, we found that f prime of x is equal to 2 times sine of x times cosine of x.